Hello and welcome. In the previous lesson, we discussed and understood the configurations provided by the Atmega 328 microcontroller to place the interrupt service routine for reset and the interrupt vector table in different memory sections. We shall place the interrupt vector table at the start of the application section, that is, the address 00 of the program memory. But how do we instruct the linker in the compilation process to place the interrupt vector table at the address 00? The interrupt vectors are position dependent and must be placed at particular address. In this lesson, we shall learn how to instruct compiler, particularly the linker program, to place the interrupt vector table at the desired address location. Linking is a stage in the compilation process where the executable file is generated from the object files provided. It is carried out by the linker program. Apart from resolving the symbols, linker assigns addresses to different sections of the compiled code. For our purpose, we are concerned with three sections. Those are .text, .data, and the .bss section. The .text section contains the executable code. .data section contains the global variables which are initialized, and the .bss section contains the global variables which are not initialized by the programmer. The .data and the .bss sections may be absent if the program does not use global variables. You can examine these sections in the disassembly file generated during the compilation process. Here is a program which blinks a LED connected to the pin number 13 of the microcontroller. I have defined a few global variables. The identifiers test_string1 and test_string2 define character arrays which are initialized, and temp_string1 and temp_long are character array and long integer respectively, which are uninitialized. This is the disassembly file of the program. The very first section is the .text section. It contains the executable code where you can find all the functions defined in the program. For example, the function main __int0 _isr are placed in the .text section along with the other functions. Then, in the .data section, you can find the global variables test_string1 and test_string2, which are initialized in the program. The .bss section follows after that. It contains the global variables temp_string1 and temp_long, which are uninitialized by the programmer. You can also find the sections like .debug_info, debug_avrev, and others. You can see the different sections in the object and executable file by using the object dump program with the -h option. For now, we are concerned with the three sections mentioned earlier. The placement of the interrupt vector table is achieved by using custom linker script. Let's understand the basics of linker script first, and then we shall discuss how the vector table and reset interrupt service routine is implemented. When the program is compiled, the linking takes place after the C and assembly source files are compiled. The object files, that is the .o files, are input to the linker and the executable is produced, that is interrupt.elf in this case. The highlighted command carries out the linking. The -a flag in the command is used to specify the machine, that is AVR5, for which the executable is to be generated. The options minus no start files and minus no default libs instruct the linker not to use the standard system startup files and system libraries when linking. Then, custom linker script named linker is supplied to the linker program with the option "-t". The list of input files follows after the "-t" option. The "-o" flag defines the name of the executable file generated in the linking step. The linking process is controlled by the linker script written in the linker command language. The script describes how the sections in the input files should be mapped into the output file and the memory layout of the output file. The linker always uses a linker script. If it is not supplied, the linker uses a default script that is compiled into the linker executable. Here is the linker script used for our purpose. The section command describes the sections in the layout of the output file. I have defined the three sections as discussed earlier, namely .text, .data, and .bss section. The .text section starts at the address 00, then .data and .bss sections follow in the sequence. The commands following the .text in curly braces instruct linker which sections from the input files should be placed in the .text section. The first line in the curly braces defines the sections named .init0 in all the input files to be placed in the .text section. Similarly, the asterisk followed by .text in parentheses in the third line defines that sections named .text in all the input files to be placed in the section .text following the section .init0. The wild character asterisk matches all the input file names. The line with .text asterisk matches all the sections starting with .text . For example, the disassembly file of prog.o contains a section named .text .startup. This section is matched by .text asterisk and placed as defined. The linker may remove the unused sections if link time garbage collection is used. Keep command is used to instruct the linker not to eliminate the section. The sections .init0 and .finit0 are critical to the working of the microcontroller and must not be removed. These sections are important ones and are used in the C code defining the interrupt vector table and reset ISR. Similarly, the .data block defines which sections should be placed in it. The sections .data in all the input files, the section names starting with .data the sections .ro data and the section names starting with .ro data is placed in the .data section. The .bss section is also defined in the same fashion. The provide command is used to define a symbol only if it is referenced and it is not defined by any object included in the linking stage. The symbols such as __data_start are used in the interrupt.c source file. The usage of these symbols is discussed in the later lesson. Before concluding the lesson, let's summarize the actions carried out by the linker based on the linker script. The script defines three memory sections for the output files. These sections are .text, .data, and .bss section. Then, placement of the sections from the input files are defined for each output section. Among all, the input sections, that is .init0 and .finit0 are important. The .init0 section define the interrupt vector table, reset ISR, and other few sections to be placed at the beginning of the program memory. The .finit0 section is placed at the end of the executable image. In the next lesson, we shall discuss how to define C functions for vector table, reset ISR, and other important functionalities. With this, we come to the end of this lesson. Thank you and happy coding.